Hi, Dave here at Albion, and I am delighted to welcome Professor Tony Kenyon from UCL and co-founder of startup Intrinsic Semiconductor Technologies. Welcome. Thank you for coming to join us.
Thank you. Thank you, David. Thank you.
So Intrinsic, you started in 2017 together with Adnan Mohanik and Wing Ning, who were leading researchers in the field of non-volatile memory at UCL. We first met you just before that in 2016, and we were able to give you some proof of concept funding to help get things going. And then we led your seed round when you spun out from UCL. And Intrinsic are developing a non-volatile memory, a new form of ReRAM. You're going to talk all about it shortly, but is a very exciting technology that could change lots of the electronics we currently use today. And to date, you've had over £7 million of funding from ourselves, as well as Octopus and IP Group, with a Series A, which was completed in 2023, early 2023. Welcome, and tell us a little bit about yourself and a little bit about Intrinsic.
Great, thank you. So first of all, I'm a professor at UCL in nanoelectronics, and also the Chief Scientific Officer of Intrinsic, which span out from some research that Adnan, who was my ex-PhD student, started in about 2010, 2011, around about that time. The work that came out of this, we looked at it and we thought, well, this is something that looks really not only scientifically interesting, but probably also has potential commercial value as well. We saw that we developed or discovered a material and a way that we can put that material into a device that allows us to create memory chips that are somewhere between 100 and 1,000 times more power efficient than existing memory chips that are out there. Also, they're cheaper to manufacture, they're very simple, and we thought there's a really good prospect of taking this and making it into a commercial reality, which is why we thought about contacting UCL Business, and then through UCL Business, the Technology Fund, and that's I think when we first met. So it's been a very exciting journey.
Yeah. The field you work in, nanoelectronics, is by its nature very applied and very close to the kind of commercial world. What was it about the memristor technology, the resistive RAM, that kind of sparked it to be, okay, this is now something we're actually going to take forward, compared to some other research projects and other innovation and inventions that you've been doing? So you've been in academia for a while.
For a while, yeah. I won't say exactly how long, but a while. I think it was when we saw the first results from just those very early devices where we thought there's something really interesting going on here. And once we started running the numbers, we realized quite quickly that there was quite an advantage that our technology had over the incumbent technology, flash technology, which is in just about everything. It's in your mobile phone, it's in your laptop, it's in your car, in your coffee machine. So we just thought, well, there's something in this. We can see that it needs a lot of development, but those initial results were very tantalizing, very promising.
Great. So you thought there's just such a big technical differentiation here that it can survive the journey through commercialization and translation and into the real world, and still, all the difficulties of that, its differentiation is so great that it will make it and become an interesting and adopted technology in the future.
Certainly that, and I think there's a bit of naivety as well, because we didn't realise how difficult it would be to go through that journey. But it's been a challenge and an interesting challenge, and valuable.
And so back in those early days, we met and we put some what we call proof of concept funding actually into the university, I think originally, to sort of help get things going. I think did a bit of technical work on a wafer that you were working on.
That's right.
But actually, a big part of the funding was finding a CEO. It's always been very clear that you and Adnan see yourselves as the sort of technical and scientific brains of the business, but you wanted to bring in that kind of commercial side from outside the university. What sort of led you to that thinking, rather than saying we're going to be the CEO and run it?
Well, I think we had to be honest about where our skills lay, and that certainly wasn't in the business side, pitching for money, creating a business, creating a company. We always saw ourselves as being much more the scientific and technical drivers, because that was our experience, certainly my experience for many years. So I think when you're starting something new like this, when you're going into a new area that you don't know anything about, starting up a company, I think you really should be bringing on people who have the expertise that you need. And I think that's why we thought, well, we'll leave the business building piece to somebody who has experience in that area, who knows also the commercial landscape. I think that's really important. You don't always, as a researcher, know the details of the commercial landscape. You might have an idea that this sounds like it has some commercial legs, but until you speak to somebody who really knows the environment, the ecosystem around your potential product, you're never really sure. So I think it's extremely valuable to bring on someone as early as possible, I think, to give you that perspective and also to help build the company. So we had to be realistic about what our skill set was.
Great. So very high levels of self-awareness and
So,
humility,
yeah.
which has been really helpful.
Caution.
And then we worked through a few options actually before Mark came in as CEO. As part of the PSC funding, we went spoke to recruiters and we did a piece of work. We spoke to a couple of options, had someone look at it, wasn't quite right, and eventually came across Mark, and he's been CEO ever since. What advice would you give to academics who are bringing commercial talent in? What were you looking for? What should you have been looking for? Is it all the same? Like, have you figured out things now that you should have told yourself back in 2016?
Yeah, I suppose there's a number of things. So one is, clearly, as I said, you want somebody who has that market knowledge, that commercial knowledge. And that's not just about what the market looks like, but what the models are for companies who might be going into that marketplace. And that's very different depending on what sector you're working in. So certainly that. I think the other thing is to also, you're going to be building a long-term relationship with somebody who comes in as a CEO or a business advisor. You need to take time to work out how you're going to speak the same language. You won't speak the same language when you start because you're coming from very different backgrounds, and you have to take time to build that relationship and understand the motivations from the commercial side as well as the motivations that we have from the scientific and technical side. So I think it's really important to build a relationship.
Yeah, it's a fascinating point, and one that we think about at Albion quite a bit. I mean, a deep tech business from university to exit or to commercial success has on average a longer time span than the average marriage.
That's an interesting statistic. Yeah.
So it's worth thinking about the chemistry, and you said there's the relationship. Yeah. It's a long-term relationship you're building. So it's not always been easy, I think, to mesh those cultures, that sort of academic culture and that commercial culture, and something I've seen you guys working quite hard on throughout the time.
In my experience, a big part of success in anything is being able to communicate.
Yeah.
Miscommunication is often at the heart of where things go wrong, where things fall apart. So try and build that as early as possible.
Is that advice for marriage or for
everything? Certainly for marriage.
Yeah. I think my wife would agree.
Yeah.
And after we had funded we did this form of funding where we loaned money to the university, which helped find you a CEO and helped do a bit more technical work.
Yes.
And then at that point, we helped you spin out of the university. What was it that you think that gave the innovation the kind of escape velocity they needed to become a spin out and grow?
A number of things. So one is knowing that we had the support of the university and the tech fund. I think that's really important to have the two together. The other thing was we're working in a field where it's really important to have a proof point very early on. The technology that we're working on is a very expensive technology to develop, as we're finding as we go through this journey. But in order to even get, I suppose, a seat at the table to talk about how exciting the technology is, you need to be able to demonstrate that you can create something that is a little bit beyond what can easily be created in a university. So we were fortunate with that proof of concept funding to be able to go and speak to a sort of research foundry that existed at the time in the US and have them prove that we can take the technology from a university lab and put it into what's quite an early stage semi-commercial but nevertheless more capable foundry than we were able to access at UCL. And I think that made a big difference because that allows us to then talk with more confidence about the technology and about the portability of the technology into a commercial environment.
Yeah, excellent. Yeah. And what other ways did the company benefit from having a kind of fund embedded in the university like the UCL Technology Fund that Albion managed?
Well, we felt we had a critical friend, and I think that's really helpful, particularly in the semiconductor business where it's hugely competitive. And when we were starting to think about spinning out and raising the first investment proper, the environment, particularly in the UK, was very difficult around semiconductors. It's not easy now, but it felt almost impossible then. So having a critical friend who understood that journey from being part of a university to then going into the big wide world as a spin out, I think was very valuable.
Yeah, I mean, it was an interesting time actually, because I remember doing the POC funding and then working with you to bring together your initial seed round. And as you say, the environment at that time, semiconductors were not loved. And I think we must have spoken to every VC in Europe, to try and build a syndicate to help the company escape the university and become a spin out. It's actually changed quite a lot in the last few years, even down to you see figures like Sam Altman raising 7 trillion or so for semiconductors. I remember emailing your pitch deck to a very well-known deep tech VC in the UK, famous for having done semiconductors in their past, and getting a 3-word reply which said no to semiconductors.
We got a lot of that, I think. Yes.
Yeah, we really did. But now, how do you feel the environment is now? What's your experience? You've done some fundraising recently. You're also now thinking about fundraising again.
Yes.
What's your perception?
It's changed. It's changed for the better. It's not, as I say, it's still not easy. It's still an uphill struggle. And I can't really sort of compare that to other areas. Maybe it's easier in pharma or AI, I don't know. Yeah. But in semiconductors, it's still hard. But things have changed, and I think the conversation has changed a little bit because we've seen a lot of talk internationally, not just in the UK, but internationally, about the dangers of the over-reliance on a very globalized semiconductor supply chain. So there's a lot of talk about onshoring and thinking about sovereign capability in this space. So I think that changed the tone of the conversation. And then we've had things like the CHIPS Act, both in the US and in Europe, and in the UK. Last year in 2023, there was an investment of $1 billion into the recently published semiconductor strategy. So at least that conversation is changing, and I think investors are seeing that and thinking, well, actually, there may be something here in terms of a future for semiconductors in the UK and in Europe more broadly. So although it's difficult, I think it's changing. I think we're still in a state of flux, but things are easing a little bit.
Which is good, because it makes fundraising slightly less painful and stressful.
Yeah, it's still painful and stressful.
Still painful and stressful, yeah, absolutely, absolutely. But you were successful in the very end of 2022. You raised your Series A, yes. £7 million, and you're now busy working on the company since then. How has progress been? What have you managed to achieve since Series A? It's
been brilliant. We've been really happy with everything that's happened, really all the way through, but particularly in the last year or so. We've had some really excellent results. What the funding has allowed us to do is it's allowed us to develop that technology in partnership with IMEC, who are a big research foundry based in Belgium. They have state-of-the-art facilities that there's no way we could afford to have that at a university. And they also have a depth and breadth of a network with all of the major semiconductor companies. So we get the experience, we get the capabilities that they have, and we get the network as well. And that's really helped us to kickstart and really push forward our technology. And in the last year, we've had some quite, for us, major breakthroughs where we've really got to the point where the technology has got beyond where we would expect it to have got to at this stage of development. And that's meant that the investors, yourself included, have said, we need to accelerate this. And of course, I'm fully behind that. We want to accelerate this as much as possible. And that's why we're now looking to raise, really in the middle of what would have been the current funding period. So we're raising early because of the results that we've managed to achieve. It has been really fun, actually, the last year. Every board meeting, the sort of excitement from yourself and Adnan about the achievements and the numbers and what you're seeing back in the data has been, very, very enjoyable to watch and be part of. Just compared to you've developed technologies in academia and researched things for for a while, as we said. How would you describe the difference? You're now developing a technology in a company as opposed to inside the university. What's the key difference? Do you put some of the kind of amazing technical progress down to the fact that you're doing it in a different environment, or how would you describe that? Well, it's absolutely down to the fact we're doing it in a different environment. We can move more quickly because we have the resources that are available to us through this partnership with IMEC. So there's a team that we work with in IMEC of 7 or 8 people who really enhance what we can do at UCL. How is it different? Well, I think that's one thing. We can make faster progress. The capabilities that are available to us are at a much higher level than at university. But I think it's also it's a combination of things. It's the fact that we have that, and it's also the fact that I still have a position at UCL, and I can draw on the experience and the facilities at UCL, which complement those that we have in IMEC. So I can walk down the corridor and talk to colleagues in physics about fundamental modelling of the materials that we're trying to develop to try and improve the process that we're trying to implement in industry. So it's a combination of all of those things, I think.
So what will 2024 bring for Intrinsic? What are you looking forward to?
Well, we hope that we'll be able to close the next round of funding, which will enable us to accelerate. And that means that we're going to, we hope, get to the point where we're able to design our first test chip, which may not sound like a big thing, but that is a very big thing in the semiconductor world. So far we've been working on creating individual memoristic devices. These are the memory elements that store the individual bits in arrays, small arrays, with some very basic electronics to drive them. When we build a test chip, that will have everything on the chip to drive the memory, to do processing, to interface with the outside world, to do error correction, and all these things. And another part of what the funding has allowed us to do is expand the company. So we now have essentially two teams. One team that is trying to develop the underlying technology, the memoristic devices, and another team that is now starting to look at IC design, designing the chips, designing the read circuitry, the write circuitry, the interface circuitry, and so on. And it's really exciting for me because that's outside my area of expertise, and that's on my comfort zone, if you like, because I'm a materials and devices person. And interfacing with these people who are designing the chips has been really valuable because it's an iterative process. So we can go to them and say, well, this is what our devices can do. And they will say, okay, we can design a chip around that, but if you could get your devices to do this, or do it slightly differently, or slightly higher voltage, slightly lower current, or whatever it might be, then there's that sort of communication both ways, and we each start to talk each other's language. And it allows us to make progress very rapidly.
And does that, these experiences that you're getting with these sort of interfaces with, areas that are sort of adjacent to where your core research is that allowing you to bring back ideas and thoughts into your core research at the university? Is it sort
very
of
much so?
Yeah,
very much so. Yeah.
So it benefits the kind of university in a kind of fundamental research way as well as just all the other.
Yeah, very much so. It can suggest slightly different directions for research, slightly complementary directions.
Interesting. So how long before my smartwatch has intrinsic ReRAM in, do you think?
Yeah, so I should learn never to really make predictions on these things, but as soon as possible, let's put it like that. Maybe it really depends on how the next 18 months pans out. So whether we're able to raise funding, create that first test chip, but hopefully maybe within 3 years.
Yeah. Just going back to the kind of team aspects of Intrinsic. So Mark, as you said, you brought him with what we would say is deep domain experience. So, a real understanding of the market and of the commercial world around semiconductors and the processes that are involved in taking innovations from through big companies, and yourselves who've spent years on the fundamental innovation and the kind of the deep science behind it. How have you worked to kind of build the culture within the team so that it's sort of stable and works well for the future?
Yeah, I mean, obviously it's been challenging because, as I say, you need to make sure that you speak the same language, you align your goals and so on. But in some ways not as difficult as you might think, coming from academia, because one of the things which I think is probably not unique but quite special about UCL is the fact that certainly engineering is very interdisciplinary. So I can walk down the corridor and speak to experts in quite a variety of different fields that are adjacent or sometimes quite distant from my own field. And that's easy to do in UCL in a way that perhaps isn't so easy to do in other universities. So I've moved my research area several times in my career, which has meant that I've had to learn a new area, learn to speak a different language, learn to work with a different group of people. So I think the process of having done that for a number of years has set me up well, and I think Adnan as well, to be able to do that in this environment where it's a more commercial environment.
Interesting. I suppose another sort of culture that you've had to interact with is the world of investment.
Yes.
What have you learnt about investors and VCs in particular?
It's a very different world. Okay. But to be honest, that's one of the reasons why I wanted to do this at the beginning, is I thought this was an interesting challenge to move into a different world and see things from a different angle, not just the research, but commercialization. I sort of characterize this with when I say to people that as an academic, I'm very happy to stand up at a conference, even a large international conference, and say, here are all the wonderful things that we've done, look at this research and so on. You stand in front of investors and that's out the window. It's like, okay, you're from a good university, we'll take it as read that this is smart stuff. Now, how am I going to make a return on my investment? What does my business plan look like? What does the market look like? And I think that's been a real learning curve, to start to think about those things and then talk to people who know more about that than I do. So I've been learning a lot in this process. I still think it's a good idea, or was a good idea at the time, that it shouldn't be the academics who are out pitching for funding and having those meetings with investors. That's why you want to have someone like Mark. But now I can appreciate a little bit more how a pitch is put together and the things that investors are looking for. And it's just been a really fascinating journey.
And actually, you did secure the very first bit of funding without Mark. So you were pitching to us right at the start. So
at a very low level, I think.
Well, we're very friendly, the UCL technology firm. But you were able to articulate. We got excited very early about what you were doing, and I think you were able to transmit that. Actually going right back to the start of the conversation, that technical differentiation and what had got you excited when you first saw sort of Adnan's results when he was doing his PhD work and beyond, like, you transmitted that excitement to us very effectively, I think.
I think that's key, isn't it? It's about that excitement.
Yeah.
You've got to get people involved in the excitement of the story, and then hopefully everything flows from that. Yeah. If you go in and bore people senseless, then you're not going to get any.
We've never done that. It's always been an exciting journey with Intrinsic. You now have quite a few hats. So you obviously you have your own research. Mm-hmm. You have your role as Chief Scientific Officer at Intrinsic. You also have administrative responsibility within the university, within the department. How do you fit it all together, make it work? How do you make your work-life balance feel appropriate?
Yeah, that's one of the biggest challenges, I think, because it's very easy. One of my weaknesses is that I find it very difficult to turn down opportunities and to say no when someone asks me to do something else, when I help someone, and then I realise, my diary is ridiculously full. I've learned to say no a little bit more. It's still a bit of a learning process. But general work-life balance, you've just got to try and find time and make time for things outside of work. And I think it really helps to have outside interests that are nothing to do with work. So in my leisure time, I play the drums. So I'm a jazz drummer when I can be. So I think that's good because that gives you a whole different outlet, it's a creative outlet as well, but it's also a total contrast to what I do during the day.
Yeah, very good, very good. Well, You'll have to show off your jazz drumming at some point. At Albion, we have a few musicians, and there is in fact a VC band out there that plays or something. So you never know where this could take you. Yeah. A lot of entrepreneurs will talk about mentorship and people who give them advice and help them on the way. Who's been instrumental in your journey through this kind of entrepreneurial?
It's several people. I'd put you in that category. So conversations we've had, I think, have been enormously valuable. Contacts that we've had at UCLB early on, I think, have helped sort of crystallise some of that initial thinking. And then it's largely the investors. So you and Lee at IP Group and now Owen at Octopus. I think I'm sort of watching closely how things work and learning, and I think that's been very valuable.
Great. Yeah. No, I think it's been nice. There's there's a good selection of sophisticated deep tech investors working with you, and hopefully you're getting the value out of that.
Oh, definitely.
That's really great. Maybe a difficult question now. Failure is a big part of startups, and most startups fail. Can you kind of think back to kind of a setback that you've had in the journey so far, how you've overcome it, like how it's prepared you to kind of keep overcoming failures and challenges?
A setback for Intrinsic?
Yeah, or for you, whatever you prefer.
Well, I mean, I start by saying that failure might be a big thing in startups. It's a huge thing in academia as well. So people don't necessarily realise this, but in academia you have to get used to your grant being turned down, your paper not being published, and so on and so forth. So it's a constant stream of rejection. So one of the things, if you're a successful academic, you really need to develop quite a thick skin in that respect. And you have a failure because you haven't got this latest grant. So you go home, you slam all the doors. The next day you have to come in and just move on from that and move on to the next thing. So I came in with that. Okay. In terms of setbacks that we've had at Intrinsic, well, we've mentioned the difficulty of getting funding. We've had one or two technical setbacks where there's been a problem with the processing of our devices at IMEC, and we've got the initial results, and we've thought, oh no, this is terrible. This is all turned to rubbish. What do we do here? But we've managed to recover that, because what we've tried to do, the team that we've got is a wonderful team, really smart people, both in Intrinsic and the people that we're working with at IMEC. And what we've been able to do is to say, well, this bit may not have worked. Maybe these devices weren't processed as well as they could have been, but we learned something from that. And what we've been able to learn is valuable in being able to then determine what the future direction is. Do we have to change the design of the devices somehow? Do we need to think about the way that we process them? So I think there's been one or two of those technical setbacks, which haven't been major, but they've been points where you suddenly take a breath and you think, okay, we need to look at this again. But I think that experience of being used to failure and rejection, and then thinking, I've got a really good team here, let's now just sit down and analyse that, has allowed us to move on.
Great. So last question. Thinking back to the early days of Intrinsic, what advice would you go back and give, Tony, a 2016 version of Tony, or an academic now who's thinking, I want to, I see something exciting in my work, I want to take it forward. What were the key things you would go and tell them?
So I'd say do it, for sure.
Great.
Definitely do it. But go in with your eyes open, go in prepared to realise that when you're in academia, you're the expert. But when you go into the commercial world, you're not the expert. You're low down on the ladder, if you like. You're going to have to learn a lot in order to make this a success, and enjoy doing that. As an academic, you should be used to learning new things. This is just a different set of skills that you're learning, or a different set of knowledge that you're learning. Do that and enjoy it.
Yeah, I mean, that's really interesting to hear. I mean, your mixture of curiosity and humility has actually been really important to sort of help bring Intrinsic,
you should have both.
And having both has been, I think that's something that I would like a lot of people to come and chat to you about. So I think you're inspirational on that front.
Yes, so. Thank you.
Well, look, thank you for coming in to chat. I'm really excited about what the next year and the next years hold for Intrinsic. It's been an absolute pleasure and privilege to be part of the journey with you. And I look forward to many more years.
Thanks, David. Appreciate it.
Thank you.